Hi everybody, welcome back to the Shukun Math Practice Lab, Learning Through Practicing. And today we're going to start a new topic. We're going to talk about implicit differentiations. We're going to take a look at our practice set number 1, how to find the y prime and one double prime by using the implicit differentiation methods here. So here, we're going to divide this topic into 2 videos here. So the first video, we're going to work on 7 practice problems. Basically, we're going to use the implicit differentiation method to find the first derivative. Then the second video, we're going to use the implicit differentiation method to find the second derivative of the y primes here. So if you already learned about implicit differentiations, and now you can pause the video and try to work the problem by yourself first to see, will you be able to get it? And then when you finish, then resume the video, and then we can, work together and check the answers here, okay? So now, if you want, now is a good time to pause the video and to try to do the problem by yourself. And I'm going to the whiteboard to get a start to do the discussion for these sections here, okay? All right, and I'm back at the whiteboard. I hope that you got the time and the chance to work some of the problems before we go over it. Okay, so today we're going to talk about the implicit differentiation. What is the implicit differentiation means here? So what we learned all the way in the derivatives, right? So we always be able to, like I said, y is equal to f of x, right? So the x could be any type of the function, like maybe x squared plus 1 square root minus sine 1 over x, something like that, right? Then you'll be able to find the y primes here. And by using all the different rules here, right? I talk about the power rule, product rule, quotient rule, chain rule, or the specific formula for the trig function derivatives here. So what is the implicit differentiation? So how about if I have x, y mixed together here? So how about if I have an x squared plus y, x, and equal to, like I said, 3x cubed. How about let's do that? Then if I want to find the y prime, I'm going to do that. Then you will say, yeah, just solve for y. Yeah, sure, right? So for these ones here, you can say the yx equal to the 3x cubed minus x squared. So you can solve for y. So this will be 3x cubed minus x squared over x. So you solve for y, then you can find the derivatives, right? By using like the quotient rule, like the product rule, whatever the rule we learned that, right? So this way is fine. How about if I have some things here, right? So for examples here, I want to find, so for example, I want to find the xy squared plus y minus x squares here. So it's equal to 3 here. Okay, so for example, if I want to do this, then it will be pretty difficult to solve for y. Of course, you can try to do complete square, those things, but then it's very difficult, right? So try to find a function y is equal to some type of the f of x here, right? So sometimes it's very difficult, right? And sometimes it's almost impossible, right? Because sometimes I cannot solve that. So what is the implicit differentiation then? So the implicit differentiation said, I know y can be solved as a function of f of x here, but I just have a difficult time to solve it. So I'm treating y as a function of f of x. Then, so the main skill we're going to use for the implicit differentiation is what do we call here? is the chain rule. Okay, so what is the chain rule? So because I know y is a function of f of x, I just cannot write it out. So every time when I take the derivative of y, right? So that means that every time I take the derivatives, right? Of y, then I need to take the y prime, right? So that's because y is a function. So this is basically, I apply the chain rules here. You get that? So for example, let's try to find one. It's pretty straightforward. So I have like y cubed plus 2y minus 3x equal 4x squared here. Let's try to take a look at what is y primes here, right? So remember that the chain rule. So every time you're dealing with y, don't forget the chain rule, y primes here. So let's see here, right? So the first one is y cubed, right? So now you can say, okay, I use the power rule. So this is y squared, 3y squared. Because of you use the chain rule, right? So you take the derivative of y. So what you need to times here, you need to times y primes here. So the same one for the second ones here, right? So when you say 2y, so you take the derivative to y. So here, you know, this will be equal to 2. But the y itself is a function of x. So what do you need to times here? So you times y prime. Then for the 3x here, the derivative of x is 3. Then this one's here is what? Is ax, right? So now in order to find the y prime, you can say this one, you can factor the y prime out. So this is y squared plus 2, right? Then this is equal to the ax plus 3. So that's why you can get the y prime will be equal to the 3y squared plus 2, the ax plus 3. So, right, so because I'm the y prime, that's what I'm trying to looking for, right? So y prime is dy dx, right? Y prime is dy dx, and the y is a function of x. So every time when you take the derivative, if it has y's here, right? So that's basically the chain rule. So you move the 3, the y squared, and then don't forget the y is a function of x, so you need to have a y prime. You get that? Okay, that's the whole thing here. If you can remember, right? So remembers here, the y is a function of x. I just have a difficult time to write it out, but I need to remember because y is f of x. So every time I take the derivatives to the dy dx, I need to apply the chain rule. So that means I need to have y primes here. All right, so are we ready? Okay. So now let's take a look at the problems here. Okay, so the first problem here, right? So x cubed minus x and y squared. Remember, y is a function of x, right? Okay, so now I'm taking the derivatives here. Okay, so here, first item is pretty easy, right? So first item is what? 3x squared. Okay, so the second item here, we need to be careful. I have x, right, times y squared, right? So remember, y is a function of x here, right? So now I have x and y squared. So what rules I need to use? I need to use product rules, right? So I move the negative sign to the front. That means I need to take the derivative of the first one, hold the second one, right? So the first derivative is x. So I have y squared. Then plus, I hold in the first term, take the derivative of the second one. So this is y squared. So I take the derivative with 2y. So remember what you have here? You need to have a y primes here, right? The y prime is what? This is what is our chain rule. A lot of students lose point is because of sometimes they forgot about this y primes here, right? Then this is a plus. So the same way, the 3y, so this is 3y what? Squares, right? Every time you take derivative of y, so what is here is a chain rule. You need to have a y primes here, right? Then 1 is the constant, so it's zeros here, right? So this is a chain rule. So in here, from here to this parenthesis, this is what we use the product rule, right? Okay, so be very careful. And now the remaining will just be your algebra skill. So be careful when you FOIL it. So this is y squared minus 2xy y prime plus 3y squared y prime equal to 0. Then just like you solve for x, you solve for y primes here, right? So I can combine here, these two, right? So I can combine these two terms as the y prime. So I would say y prime will be 3y squared minus 2xy, right? 3y squared minus 2xy. Then I can move these two terms, the terms without the y prime to the right hand side. So it will be y squared minus 3x squared, right? Now I can get a y prime is equal to what? Y prime equal to 3y squared minus 2xy, and then I have y squared minus 3x squared. If you want to simplify a little bit, you can simplify, so that not much. So this is y squared minus 3x squared, right? Then you can factor the y out. Then this will just be the 3y minus 2x. That's it. Okay? Now let's take a look. So everything is the same. As long as you remember, right? Do not forget this y primes, right? Every time you take the derivative of y, you need to have that y primes here, right? So do not forget about that. Okay, so now let's take a look at the next ones here. So x e y, x minus 1. Okay, so again, be very careful, right? So we say, hey, this is x and ey. So this is a function of what? Function of x here, y is here. So the first one is here. What rule I use here? Here, this is what I need to use the product rules, right? Because you times two things. One is x and one is ey. Okay, so let's take a look at the first derivative, right? So the x, so is ey. Then plus, you hold the first term. You take the derivative of the ey, so this is ey. Don't forget, every time you're doing that, you need to do what? You need to do y primes here, right? As long as you remember this y prime, you will be okay with the differential equations, implicit differentiations here. Okay, so x, take the derivative is 1. Y derivative is, so what is the y's derivatives here? Will be 1s, right? Will be 1, and but don't forget what you need to do here. Y primes here, right? Remember this y prime. Those are the places, if you're not careful, going to kill you, right? Okay, so now move all the y prime to one side, one without one y prime to the other side, right? So this is x e y y prime plus y prime is equal to 1 minus ey, and then y prime factor out, so this is x e y, right? So this is x e y plus 1 is equal to 1 minus ey. So what is y primes here? So y prime will be x e y plus 1, 1 minus e1. You see here, it's pretty easy as long as you do not forget y primes here. All right, now let's take a look at the next one here. So this is a cosine xy and 1 plus sine y here. All right, okay, so let's see here. cosine. So this here, we have a lot of chain rules. You need to be careful. Okay, what is the cosine? So the first thing is I need to take the derivative of cosine, right? So what is the cosine? Cosine is sine, negative sine xy, correct? Then after that, what do you need to do here? You need to do the chain rule inside, right? So you need to do the chain rule inside. Here is xy here. Okay, so the xy, just like we did before, right? So xy is here. It's just like x is a function, x, y is a function of x. So what rule again? Product rules, right? So x take derivative is 1. So it's y plus x here. Then the y take derivative is 1, but don't forget what? Y prime here. Very important, correct? Okay, so don't forget this y prime. Like I said, this is the place. If you lose point, this is the place you're going to lose point, right? Okay, sine, 1 is a constant, it's 0. Sine is what? It's a cosine what? Cosine y. But every time you're dealing with y, so what is here? You need to have y primes here, right? So important part, don't forget this y prime. Okay, then the remaining will be how good is your algebra. So foil it. So the first term will be negative y sine xy minus xy prime, the sine xy is equal to cosine y, y prime here. So to solve it, I can move all the, so this is a negative y sine xy, right? So then I can move everything with y prime to the right hand side. So this is a cosine y, y prime plus xy prime sine xy, right? Then factor the y prime out. So it will be cosine y plus x sine xy, right? So finally we got it. So divided by this one both sides. So y prime will be equal to cosine y plus x sine xy over, no, this is negative y sine xy over cosine y plus x sine xy here, right? So as I said, as long as you remember this, you will be okay. All right, okay. So now let's take a look at the next ones here, right? Okay, so next problem here. Okay, so this is ey sine x plus xy. So allow the product rules, right? Because this is a function, ey is one function of x, this is another function of x. So the same is here, right? So same is here. So we have a lot of product rule to apply here. Okay, so let's take a look at this ones here. Okay, so product rules, right? Take the derivative of the first one. Ey will be ey itself. Don't forget what? Y prime. Then sine x. Then plus ey. What is the sine x derivative? It's cosine x. That's right. Okay. So this is one of the product rule. Now here, this is 1 plus. Okay, so here is another product rule. Take the derivative of x, so you have y. Then plus, you hold the x, you take derivative of y. Y, when you take derivative, is 1. Then don't forget it's 1 times what? Y prime here. All right, now let's try to figure. So here's y prime, here's y primes, right? So now let's try to combine the everything with y prime, so like move the y prime over. So this is ey y prime sine x minus xy prime is equal to 1 plus y minus ey what cosine x here. All right, as long as you be careful about your algebra, and I think you'll be fine here. Factor the y prime out, so this is ey sine x minus x. So this is 1 plus y minus ey. What is here? Cosine x here, right? Okay, so now I can get my y primes here. So this will be ey sine x minus x, 1 plus y minus ey cosine what? Cosine x here. All right. Okay. So that's it, right? So now let's take a look at the next ones here. Okay, so the next ones here, sometimes your teacher would be nice to say that don't need to, the combine or simplify. And sometimes, they do want you to combine and simplify. And, you just need to be very careful about the algebras here, right? Okay, now let's take a look here, right? All right, so here, all right, so now tangent axis, right? Tangent x is what? The derivative of tangent x is the secant square x minus y, right? Okay, so it's the secant square x minus y. Don't forget, and then the chain rules here, right? So the chain rules here, x is 1 minus y is 1 times, don't forget what here, y primes here. Got it? Right? So don't forget this y primes here, right? Okay, so now, then the other side here, this is equal. Okay, so this one's here. What rule we use? Quotient rules, right? So what is the quotient rule? Okay, so this is 1 plus x squared. You square the bottom. Then you take the derivative of the top first. So it's 1 times y prime minus you holding the top, and then you take the derivative of what? Bottoms, right? So it's 2x here. All right. Okay, so now the things here, we just try to simplify it and make sure we're not, so this is, we make sure we're very careful about our algebra, right? So this is the secant square xy minus y prime. This is the secant square x minus y. And then this is what? This is 1 plus x square to the square, and this is y prime, right? This is y prime, and right, because I can, so the y, if I want to make it a little bit, I don't want to skip the step, so you will understand. So this one is y prime minus 2xy 1 plus x square, right? I just try to simple, don't want to skip the step. This is 2xy, so this is 1 plus x square. Okay, so now it's good. So I move everything with the y prime to one side, other one to the other side, so I can move this one. So I said that this is the secant square x minus y plus 2xy 1 plus x squared to the square, right? Okay, so then here I have here, this is 1 plus x squared to the square y prime plus y prime secant square x minus y. Not bad, not bad. So it's getting a little, so this is y prime, right? So this is 1 over 1 plus x squared to the square, then plus secant square x minus y here. Right? Okay, so I guess that, you know, so then you can finally, so you say y prime will just be 1 over 1 plus x squared plus, right? So this is 1 plus what? Plus secant square xy. All right. So now here, okay, so the top here, this will be y prime 1 plus x squared to the x squared and the plus secant square x minus y, right? I just find out I made some careless mistakes here, just like when we talk about don't make the mistake I made here. So here, okay, so we use the quotient rule, so then you need to hold the bottom ones here. I forgot that, and then minus, now this is y times 2x. Now it's correct. Okay, so the same ones here. So these ones here, I will have y prime. This is 1 plus x squared. Oh, okay, that's much better here. Okay, so here I need to be careful here. All right, so here the y primes here, right? So the y prime, so this is the y prime 1 plus x squared. Okay, so in fact here I can simplify. This is 1 plus x squared. Here is 1 plus x squared. Okay, so now I combine the y primes here. So this is the secant square plus 2xy, 1 plus x squared. Now here this is y prime, but there's no squares here. Okay, then plus y prime secant square x minus y. Okay, so good. So here, so that's why here, no squares here. So this is y primes here. So y prime will be 1 over. So here I need to be careful. It's no squares here. 1 plus x, right? 1 plus x squares, no squares here. Secant square. And my left-hand side here, here, I'm not careful here, this is 2xy. Okay, that's it. And if you want to simplify, you can continue simplify here. That's what I say, you know, when you do this, you just need to be careful about the algebra. A while ago, when I tried to solve the problem, I did not pay attention and just write it down into the wrong things. Here, just be very careful about you know, when you apply the quotient rule, different rules here. All right, so sounds good. Now this one is kind of like very tedious, right? Let's take a look at the next one, the xy, the square roots of x squared plus y squared. Okay, so the first thing, this is x, this is y, right? So what the rule? Product rules, right? So make sure this time I do not make any silly mistakes here. So product rule, take the derivative of x, so it's y, plus hold the x, take the derivative of y, is 1, then it's y primes here. Okay, so this is the x, so the x squared, so this is really is x squared plus y squared, a half, right? Okay, now I'm going to use the power rule, bring the 1/2 out. So this will be the x squared plus y squared, then 1/2 minus 1. Then chain rule, then chain rule inside, right? Okay, so this will be 2x plus 2y. What do you need to do? Hey, don't forget y primes here, right? That's good, right? So make sure we remember all this y prime so we don't make silly mistakes here. Okay, now let's try to combine it carefully and also don't make any silly mistake. Okay, so this one's here is, okay, so this one's here will be 2. So here basically is x squared plus y squared because it's negative, right? So here this become negative 1/2, right? So become to the denominator. And then here I can factor the 2 out, right? Okay, so I can factor 2. So this is x plus y and y primes here, right? So after I factor, this one I can cancel. Okay, so far so good. So now I need to use the same skill. I'll say here I need to divide, separate this fraction into a 2 so I can combine the y prime. So this will be equal to the x, then plus this is x squared plus y squared, y and the y prime. So far, so good. Okay, so I move the y prime to the left-hand side. So this is xy prime minus y over y prime. So this is x squared plus y squared. Then this will be x. This is x squared plus y squared minus 1. All right, so now I can say y prime. Okay, so here you can factor the y prime out. So this is y, this is what? This is x squared plus y squared. All right, okay, this is x squared plus y squared. Okay, so now my y prime will just be, this is x minus y, x squared plus y squared. Then this will be x squared plus y minus 1. Right. So some of the, most of teachers will say, okay, as long as you did it so far, it's good. Some of they will want you to combine. So the combine, basically, you just find the common denominator. So let me try to combine a little bit. So get your feeling so you know how to do those type of problems, right? So these ones here, if you combine, so the common denominator is x squared plus y squared, right? So this is x, then this is minus y times x squared plus y squared, right? Now here, the bottom, the same way, you can combine this x squared plus y squared. Then this is x times x squared plus y squared and minus y here, right? Then you flipped it and so the final answers here, this will be x minus y square roots of the x squared plus y squared. Now here this will be x here, the square roots of x squared plus y squared minus 1. You simplify a little bit, but it's not that much. So sometimes, like I said, most of the teacher, you'll be okay. You leave the form like that, but depends on your teacher. If your teacher wants you to simplify more, then make sure you simplify more, right? Okay, so last problem for this video. And so this one is gx, is x sine gx at x squared. Find the g primes, right? Okay, so this one's here, we say, okay, find the g prime. So I'm taking the derivative to the x. So the first one is g prime x. Okay, so this one's here, we have, we did this several times. We have x, and we have a function of x, right? So what rules again? Is what? Is the product rule. So take the derivative. Take the derivative, first one. So we'll give you sine gx left. Then plus, hold the first one, take the derivative of the second one. Sine x is what? It's cosine gx. Aha, don't forget what we need to do here. We need to do what? We need to have chain rules, right? So don't forget that g prime x, right? Okay, so now the right-hand side of the equation will give you the 2x here. So now you want to find the g prime 0. That means I'm going to find x equal to 0. So when the x equal to 0, this number will be equal to 0, right? Okay, so let's see here. That means g prime 0 plus sine g0 plus, and so the here, right? So the g prime 0, so the g0 is here. So here, then this is 0, right? So it's 0 times cosine g0, and that times g prime 0 is equal to 0, right? So then I have here, right? So I have a g prime 0 plus sine g0 equal to 0. So what is g prime 0? Okay, now if you go back to our original, so our original you can say here, right? So you can say here, so this is g0 plus 0 times sine g0 is equal to 0 to the squares, right? Okay, so that's why, because so this one's here, we know, so this one is zeros here, right? So the here, so we know the sine g0 is equal to what? Sine g0 is equal to what? Equal to zeros here, correct? So that's why I know the g prime 0 is equal to what? Is equal to zeros here. And that's it, right? So that's the practice of what we have today. So for the implicit differentiation, so it's a first derivative. So remember, you know, the y is a function of x. So every time when you try to do it, do not forget to use the chain rule. And so you need to have y primes here, right? Okay, so that's it. And please, you know, make sure you practice and practice and practice, right? So don't forget that very important values here is what is y prime. So anytime when you try to do the derivative of y, you need to have that y prime here. Okay, that's it. And our next video, we're going to talk about how to find the second derivative. So the second derivative is a very tedious. It's not hard. It's follow the same method. It's just the algebra part is super tedious here. All right. So look, you know, very excited to talk to you about the second derivative, how to use implicit differentiations. And that's it. And have a good day. And don't forget to practice. Okay. Looking forward to talk to you in our next videos. Okay. Bye.